In incompressible fluid dynamics, dynamic pressure is the quantity defined by, or where, physical meaning. Dynamic pressure is the kinetic energy per unit volume of a fluid particle. Dynamic pressure is in fact one of the terms of Bernoulli's equation, which can be derived from the conservation of energy for a fluid in motion. In simplified cases, the dynamic pressure is equal to the difference between the stagnation pressure and the static pressure. Another important aspect of dynamic pressure is that, as dimensional analysis shows, the aerodynamic stress experienced by an aircraft traveling at speed is proportional to the air density and square of, i.e., proportional to. Therefore, by looking at the variation of during flight, it is possible to determine how the stress will vary and in particular when it will reach its maximum value. The point of maximum aerodynamic load is often referred to as max Q, and it is a critical parameter in many applications, such as during spacecraft launch. Uses. The dynamic pressure, along with the static pressure and the pressure due to elevation, is used in Bernoulli's principle as an energy balance on a closed system. The three terms are used to define the state of a closed system of an incompressible, constant-density fluid. If we were to divide the dynamic pressure by the product of fluid density and acceleration due to gravity, g, the result is called velocity head, which is used in head equations like the one used for pressure head and hydraulic head. In a Venturi flow meter, the differential pressure head can be used to calculate the differential velocity head, which are equivalent in the picture to the right. An alternative to velocity head is dynamic head. Compressible flow. Many authors define dynamic pressure only for incompressible flows. However, some British authors extend their definition of dynamic pressure to include compressible flows. If the fluid in question can be considered an ideal gas, the dynamic pressure can be expressed as a function of fluid pressure and Mach number. By applying the ideal gas law, the definition of speed of sound and of Mach number, and also, dynamic pressure can be rewritten as where